Differential calculus, a subject debatable if it is usable in your daily lives. Okay. So we have here the rate of change, we have here some applications, we have the relation of the equations. These equations very difficult and you can hardly tell what's the application in real life. In this edition of Problem Solved, one student or the watchers will surely learn what's the significance in learning or the usage of differential calculus in applications for the rate of change. So as of now, maybe you come here to my channel to learn how to do relative rates or how to do the applications for the relative rates, okay? So by now you may have known how to derive properly to find the derivative of a function, but don't know what's the application or what's the significance in learning such things. Okay, for this particular tutorial or for this particular lecture, I'm going to show you a certain application of relative rate. Okay, so relative rate, we have several applications. The time it requires to empty a tank, the time it requires for a certain object to slip, the height is growing, travel speed, whatever. Okay. So for this particular example, I'm going to use an application, the rate of change of how a shadow changes as a certain object goes far from a certain source. Okay. So for this particular problem, so let's try this problem. So suppose we have here a certain object that moves far away from the light source, wherein the shadow then changes. So let's have here the sample problem. So the sample problem reads such that, okay, so I'm going to solve it here. So sample problem. Man 6 feet tall walks at a rate of 5 foot per second away from the light. That is 15 foot above the ground. When he is 10 feet, from the base, of the light, at what rate, so we have here two conditions, at what rate is the tip of the shadow moving? And we have here a follow-up question. At what rate is the length of the shadow moving? So we have here two conditions. So the tip of the shadow moving, meaning to say the tip is moving. And the second condition is how fast is the shadow moving towards the light. So what's the first thing that we're going to do if we encounter this kind of problem? So the first thing that we're going to do is to relate or to formulate the equations. Remember, seeing the title, okay, identify, analyze, strategize, and then solve. Okay, so for this case, we identify. So that would be something like a triangle. So suppose this would be our light post, okay? So this would be our light post. So radiates lights. So this isn't the. So this would be 15 foot or 15 feet rather. So we have here a certain human at 6 feet. Okay. So that would be somewhere here. So say would be somewhere half and then here. So this would be the human. So this would be 6 feet. And then the distance between the two. So let's just leave that behind. Okay. So we have here. So I can draw a triangle from here. Okay. So I can say this would be our x. Okay. And this would be our y. Okay. All in all, this would be our length L. Okay. This is 15 foot, this is 6 foot. Okay. So how do we relate or create the equation for this problem? So the first thing that we're going to do is to create relations. Okay. So how do we do the relations for this one? So as you can see, I can create the equation out of this using the similarity theorem. Okay. So I can say that I'll have here two right triangles. Okay. So this would be one right triangle and this would be another right triangle, or that would be similar right triangles. So I'm going to relate this two and then this with this, so that I'll have 6 is to y is equal to 15 is to x plus y. So that's the first step. So we need first to create our equation. So writing this equation to a single line of text, so I'll have 6x plus 6y is equals to 15y. Okay. So how I write this equation? Okay. So to clear, that would be 6x plus y is equals to 15y. Okay. So distributing this, so that would be 6x plus 6y is equals to 15y. Okay. So let's try to isolate the variables. So that would be 6x, okay, is equals to 15y minus 6y. Okay. So solving this, so 15 minus 6y, so that would be 6x is equals to 9y. Okay. So we now have the relation, okay, 6x minus 9y is equals to 0. Okay. So we have here two parameters. The first here is the man 6 foot tall walks at the rate of 6 foot per second. That means the shadow moving or his distance moving. So that would be our rate for moving this. So for this case, we're calling this x, or that would be this part. Okay. So we'll have here dx over dr. So that would be our 5 foot per second. Okay. And that would be our hidden parameter. We know that I've renamed this equation. Okay, so x and y. Okay, so if we add these two, okay, we will have another equation such that the length is equal to x plus y. Okay, and if we're going to use or utilize this relation, okay, so let's try first isolating the zero variable x, or removing y for this equation. So how do we do that? So from this one, okay, I can say, or rather we can say, 6x over 9 is equals to y, so that we can substitute at y is equals to 2x over 3. And that would be another value for our y. We can simply substitute that here, so that the length would then be equal to x plus 2/3 x. So that L will then be equal to, okay, so 5/3 x. Or rather, so hidden here is 3 over 3, so 3 plus 2, that's 5. Okay, so we have here 5/3 x. And this will be our first equation. Finding the derivative of this whole equation with respect to the rate, we'll have here dl over dr is equal to, okay, derivative of 5/3 x, okay, so that would be 5/3. Derivative of x with respect to r, so that would simply be equal to 1. And that would be dx over dr. We have a value here for dx over dr, which is equal to 5 foot per second. So that the length with respect to the rate would then be equal to 5/3 multiplied by our dx over dr, substituting this here, which is equal to 5 foot per second, which leads us to 25 over 3 foot per second, which is our dl over dr, or the length how the shadow is changing. So this one, which is for our letter B. We've already now solved letter B. Okay, so let's cut this video for a while so that I can erase this part. So we've already solved our shadow moving to 25 over 3 fps, which is our dl over dr. Okay, so let's now solve for our rate where the tip is of the shadow is moving, or the tip. Okay, so the tip of the shadow would be the tip of the man, so that would be our dy over dr. Okay, dy over dr. Okay. So manipulating this equation again, okay, so that would be, okay, so that would be the tip of the shadow. So from this part, okay, so we can manipulate this equation and find out that, okay, so since L is equals to x plus y, we know that lately, okay, so for this time we need to change x to y. Okay, so we know that 6x goes to 9y, so instead of transposing 9 to the other side, just like what we did, this time we're going to transpose 6 to the other side. So that we'll have, okay, so x is equals to 9y over 6, which gives us 3y over 2. Okay, so using this as x, so that the length will then be equal to 3y over 2 plus, okay, 3 over 3, since this 1. Okay, so 3 over 3y are simply just 1. Simplifying this, we have the length equal to, okay, rather that would be, sorry, this should be 2 over 2 instead of 3 over 3. So this should be 2 over 2 instead of 3 over 3. Sorry. So we'll have here 5y over 2. Okay, and that will be our L. So finding the derivative with respect to r, so we'll have here dl over dr is equal to 5 halves derivative of y with respect to r, that's simply 1. Then we'll have here dy over dr. Okay, now we have our dl over dr, which is equals to 25 over 3 foot per second. Okay, so we can manipulate this. Okay, so we have here, okay, substituting it here, so we have here 25 over 3 is equals to 5 over 2 dy over dr, which is now our concern for this particular part of the problem. Okay, so if we're going to arrange this, so this would be 2 times 25 over 5 times 3 is equals to dy over dr. I can cancel out 5 and 25. This leaves me with 5. So 2 times 5, so that is equal to 10 over 3 foot per second, which is our dy over dr, which also resolves the remaining questions in our problem. So do you need any clarification or you find it difficult? Okay. So is there anything that makes you confused with this problem? So if you have problems, you have questions, clarifications, don't hesitate to send me a private message.